I'm CK. Tonight I've got a product from a manufacturer I haven't worked with before. This is the Coven LFO from Capital City Tube and Valve out of Canada. So we'll see what it looks like. It's a relatively small box. We'll see how much fun it is to put together and put another LFO in our rack, which is always a good thing. Hope you enjoy the video. Here's the box. It is a super witchy quad LFO, a DIY eurorack kit, and they've got a build guide, and again they're out of Victoria, Canada. It's not a very big or thick box, so I'm thinking a little bit that it might be a bunch of surface mount, but I don't know that for sure. We will open her up right now and see what it's all about. Some gold foil tape. Which is better than a bag. I mess it up less. Oh no, it's got lots of good parts. There's a parts bag, eurorack cable, a bill of materials with stuff in it that should be in here. So we'll check that out, and they point to the build guide on their website. Let's see what we have here. Here's the front panel, and we've got probably a knob. These may be, no, I thought they might be transparent for LEDs on the motherboard, but they're not. And a little hand going here, which indicates to me that that's probably a tempo switch. There's a frequency in, a sync in, or those could be knobs, we'll find out. And then I'm going to assume that's 1, 2, 3, 4 outs. And looks like we've got some LEDs. So that looks interesting. On the back, designed by Sarah Sedlock and Philippe P, and a part number. Here we go. At the top, that's a pot, and we've got LED, we've got jack, out 2, out 3, out 4, and the corresponding LEDs. Looks like we've got some pin headers to connect the two boards together. Nice enough looking board. All the component holes are through-hole plated, which is always a good thing. Let's look at the other board. And we've got a bunch of resistors. All the values are listed. A couple of capacitors, a couple of diodes, caps, a transistor or a power supply or voltage regulator, I'm sorry, which does not have its part number listed. I assume there's only one. Same with these three. Looks like electrolytic caps. They don't have part numbers either, or values either. There's the power connector, more resistors, and here looks like a place to put a daughter board, probably one of the Raspberry Pi, Arduino spin-off type things. But we'll see what's in that bag right now. Gotta trim the end of my pokey thing. It's losing a little bit of plastic. That's too bad. I don't want to wear that out. Here's some hardware screws and well, that's a big clear knob. I guess that'll go up here on this top pot. Oops, what is in the way? Oh, my light is in the way of the upper camera. I'm sorry. There, fix that up. Put that aside. Let's see what the rest of the stuff in the bag looks like. Bunch of resistors, and they politely put the values of the resistors on the paper tape, which is always nice. And here is the daughter board. It's the Seed Studio XIAO SAMD21. Seed Studio, made in China, but it comes out from EVA Master Consulting out of Germany. I'm not, and I may be saying all that wrong. No, EVAT Master. I'm sorry for saying it wrong constantly, but I can't really read the printing all that well. It looks like, let me open this up, because this is interesting. I have not run into one of these before, and there's a little piece of paper inside, which is interesting. Oh, I think, okay, that's the pinouts for the chip, and it's on little adhesive paper, and I'm looking to see where they're all the same. Yeah, they are all the same. So it looks like it may be a fancy A to D module, but I'm not certain of that. I'll look this up maybe if I remember. And this is Arduino. So another, again, Arduino type offshoot. I'll look that up and maybe I'll remember to say something about it on the video. Probably not. You know how I get. And I'm sorry, this light, I've been out of the country for like a month, so things got a little disarrayed. You didn't notice I was out of the country because I stacked up videos to fire off while I was out of the country. Little diode there. It's a 704 op amp. I mean 074 op amp. Jacks have all their panel nuts taken off. Same with the pot, which I appreciate. Here is a little, I assume this will be a speed tap. Yeah, it's a little stiff for a tap, but it'll work just fine. 90 degree. Oh, I see. I think we're going to be mating the two panels with this 90 degree. These 90 degree pin headers. So it'll go together something like that. Which is dandy. No objection to that. Here are little 22 microfarad, 35 volt electrolytic caps, some LEDs, and I assume these are a couple of 104 decoupling caps. These are 104 decoupling caps. And a couple of foil caps. So not a lot in here. Again, I think a lot of the brain power is in here, but it looks like a pretty straightforward kit to put together. And again, having another LFO is always good. So I'm gonna get the soldering iron heated up and bring the build guide up, and we'll start putting this thing together. I'm going to have the build guide up. It's a good build guide. It's very detailed, lots of good pictures, aimed for any skill level, including if this is your first or second build. They go into great detail and lots of good pictures and lots of suggestions for how to solder and all that. So all that's really good. So we'll start as typical with resistors, and which one do we have the most of? The most we have are the 330R, so we'll do those first, because I like to do the most to the least. That's just a psychological thing for me. I always feel I'm doing good as I go from lots left to do to just a few left to do. So we will try one to see how well the board takes solder and how much we have to bend the resistor leads. You want to leave, looks like, let me measure this instead of eyeballing it. Looks like you're going to want to bend it out at about 1.5 millimeters away from the body. Now we'll try soldering one to see how the board takes solder. Very nicely. Okay. And the solder wicks through the through-hole plated holes very well, which is the point of through-hole plating, to make sure you get a nice connectivity. You don't get cold solder joints, or you're less likely to get cold solder joints if you use through-hole plated circuit boards, because, as I said, the solder will flow down through the holes and wrap all the way around the component lead, making sure there's no gaps and good connectivity. Connectivity and conductivity all in one. But we've got a bunch of resistors to go on the board, and we've gone through one as a sample to see how it works. So we'll put all the rest of these on without further commentary, and I'll put the video replay in fast motion because it's resistor time. And since I'm not going to be talking, I will be listening to WQXR out of New York, classical music out of New York on their iPad app, and we'll be starting off with Symphony No. 60 in C by Haydn, the Distracted Symphony. Enjoy resistor time. And there are all the resistors on the board. Nothing particular to mention there. Now we've got these two 4148s diodes, and I don't know who makes these. Let me go in my parts bin and get something else out. See, typically, at least in my experience, 4148s are orange with a black stripe. Let me bring that in a little bit, see if we can focus that up a little bit. Orange with a black stripe. These are kinda yellow and not transparent at all with a black stripe. They're probably just fine. I've just never seen that before. Their board is labeled very clearly for where the cathode side, the black stripe side, goes. Even though I bent the body too close, the leads too close to the body, because these are kind of tiny, and the distance on the component holes is the same as the distance for resistors, and these are significantly shorter for resistors, so you got to leave a little more lead to the side. Not a big deal, just they're a little uneven now. The electrons won't care. Lots of really, oh, they want to put the XIAO, which is this thing here, as we talked about. It is the SAMD21 based low power microcontroller, 100% Arduino compatible. It features a USB-C port so you can power the board and to download code. It comes pre-loaded, and this contains the microprocessor, which is going to set up the waves as they go in and out. Now this is kind of surface mounty, not really completely surface mounty, but you'll want to be careful with this. I wish they had made the die on the board for this a little bigger. I would like to have a little more pad on each side, but be that as it may, we'll work with what we have and be happy to have it. Well, let me do these two diodes just so I don't mess them up while I'm doing this. So what we're going to do, as you can see, it's really clear where it goes because we've got, I have to zoom back out. Sorry, folks. So what we're going to do is we're going to mount it here, and it's easy to tell. Here's the USB-C connector, and here's where that goes. And I'm going to put a little dollop of solder on this pad. Now I'm going to take this little mini board. I don't even have to use tweezers like I usually do with surface mount. I do have to get my head in the shot though, probably. And I'm going to line up all the pads correctly and somewhat symmetrical side to side. Now I'm going to heat up that little pad of solder I put in there a minute ago. Heat it up, and you probably couldn't see it, but it's sunk in. And now the board is firmly affixed, even with just one leg applied. So I don't have to worry about it sliding around while I get the rest of these pads soldered in. I'm going to tilt this a little bit so I can work a little better, tilt my solder pad up. This is not my favorite way to do this, but I wonder if I can do that. I wonder if that'll wick down. Yeah, that does. No, doesn't really wick down the way I want it to. I've had better daughter board. That worked okay. Okay. So that worked very well. So what I did is put my soldering iron. I'm using this 0.030 30-degree bent soldering tip, and I'm dropping it down this center hole, running solder through it, keeping it in there for a little bit. And as you'll see, it's going completely through and soldering onto the pad. So that's kind of handy. But you will need a good fine point soldering tip to do that most effectively. And I use this. This is my go-to soldering tip, the 30-degree bent. Thin for circuit board type stuff. When I'm doing point-to-point wiring in a guitar amp, I'll get a straight tip then that's much broader. But for circuit board stuff, I really like this 30-degree bent. Yeah, this is this. Okay. Now once I see the philosophy behind this daughter board, it's easy to make it go in. Except when my soldering iron acts like the leg of a honeybee and just collects the solder at the bend instead of letting it go out. I hope I'm not bridging any of these. I can't really tell. That's the one thing, or one of the things I don't particularly like about the way this is installed. I'm gonna see if I can tell bridging without affecting the components on board. I'm gonna go ahead and put my my meter in continuity mode and see if any of these are bridged. Nope, nothing appears to be bridged. Good. So that's when we're going to do that. We're done with that. Oh, and then they go step by step on how to do this. Okay, now we're going to put the... Oh, interesting. I didn't even notice that. They are not using sockets for the op amps. We're just directly soldering them onto the board. Not a big deal. The likelihood that you will get a failure in this dual or the quad op amps is very, very low. So a socket just is more foo-for-all you have on the board. So I don't mind that at all. Make sure you get the notch in the right direction, or else things will not work and you will be sad, and then you'll have to desolder the op amp instead of just swapping it around. That's the one advantage of having sockets. But it's a minor advantage, because if you do it right to begin with, you don't care about that. Okay, notches are both facing the correct direction, and all the pins are through. So we will solder all the legs. One on each to start, so they don't fall out. Sockets are on. I mean, not sockets, geez, I've just been through that. The op amps are on the board. Now, we're going to do C1 and C3, which are our little decoupling op amps, the 104s. They're usually closer to the ICs than this, but it doesn't matter for this type of circuit. If you pick up a little inductance, it's not going to be too bad. This is not an audible signal that we're hearing or that it's generating. You're feeding this into something else, so it's less of an issue if you get a little voltage slop on that. Now we'll do the foil caps, and they are all the same value, which is nice. They say you don't have to bend the leads. Well, I like to. Foil caps are all on. Now we'll do the electrolytics, and they are, of course, polarized. What would they like us to do next? Yes. And now we'll do the voltage regulator. It's a 78 LFO, 5 volt, which makes sense. Oops, and we'll drop it on the workbench first. Give it the impact test before we mount it. Put the power header on. Since this is not a shrouded power connector, you don't have to care. You don't have to align the pins or connector in any particular way. It does mean that when we put the power cable on later, we have to be double sure we've got the red stripe, the negative 12 volt, going in the right way, because the shroud is not guiding us. Now, as you can see, I've got it all crooked. That's why I only did one pin, because I'll just heat that pin up, push it against the board, and it flattens out. And that, I believe, yes, that is it for this board, except for the edge connectors that we'll be connecting it to the control board with. So that's the way it looks. And I'm going to do a quick review of the back of the board with my index card, checking every solder joint. And that's that. And that's where I'm going to stop for this evening, because as I said, I've been out of the country for a month and somebody else has been taking care of the cats. And that person feeds them earlier than I do. So they are currently pounding on the door saying it is time for food. So I'm going to go feed the cats. Okay, one thing we did not do, that I'll go ahead and do just cause, is put the little sticker on the processor. Don't need to, but may as well since they gave it to us, with the pinouts of the processor listed. So we'll set that one aside. And now go on to the other board. And the first step is to put all the jacks on. And as is typical with the ground pin, it is difficult to get these wrong. You could get them wrong if you bend the pins, but if you don't force it, you'll get it right. That's what they want us to do first. What does he want to do now? Then we'll put the tap switch in, which goes in up here. And typical with switches like this, they're not square, they're rectangular, so it's difficult to put those in wrong also. What do you want me to do next, little guys? And we'll put the pot up on top. And we've got a bunch of LEDs. Now there's not a positive, there's not a plus symbol on the board for the LEDs. There is a flat side showing you where the negative, cathode, short lead, flat side of the LED goes. Again, pretty straightforward if you take your time and you find out where all the LEDs go. Oh, there's the other LED. And I didn't put a jack on, which is kind of silly. So I'll do that in a second here. The author of this kit wanted us to solder everything first. I'm not going to. I'm going to put the panel on momentarily. Actually more than momentarily. And I'm going to... I ran out of solder last night, didn't I? I did. Let me grab some more. And to make sure everything fits right, speaking of which, I was looking for the panel nuts. Panel nuts are all in another bag. So I'm going to solder one leg of this jack. If I can get my hands around it right, actually I'm fumbling a little bit, so I may as well just go ahead and grab my locking tweezers and hold the boards together like that. Solder one leg on this jack and then move my locking tweezers to the other end and solder. Well, that's not flat, is it? And solder one leg on this potentiometer. Now they're both down flat. And with those in place, I'm going to take these panel nuts over here, all out. And put one panel nut semi-firmly on the jack I just soldered. If I can get the thread started. Come on, or we could just drop it back in the parts bin for a minute. Give it a chance for it to think about the error of its ways. Man, having a hard time getting these started. So I'll snug that down just finger tight, and I'll snug the pot panel nut down finger tight. And that will hold the board down. Nothing rattles around except the LEDs, but I don't care about them right now. Double check that the push switch is free and clear and doesn't have any interference. Now I'm going to solder all the jacks and the potentiometer in place with the panel holding everything straight. And I'm going to go ahead and what we're going to do with these LEDs is push them all the way through the panel. They'll protrude a little bit, and that's okay. And now I'm going to go ahead and solder all of these connections. Now we're going to take it back apart, I think, unless he wants us to put it, he wants us to put it together like that. I don't think I'm going to do that. He would, or the author of the guide, would like us to put these two panels together with this front panel on. I'm not going to do that. It certainly is a reasonable thing to do, but I like to have a little more access to the solder points. But first thing I'm going to do is put all these pin headers on. I'm going to do them one at a time because I want to make sure they're perpendicular once I get them on. So as is typical, I'll do one leg, cool off a little bit. Take a look, and that is not quite perpendicular. So I'll push on it with my index finger, reheat that solder ball, and there. That's perpendicular on that one. Now, I will mate these just to make sure that they are going to fit. Yep, they're all going to fit. So that will all fit together nicely, so I'm going to pull this back off and final solder all these connections. And once again, put this on. You can only, the pin headers are arranged so you can really only put them together one way, the boards together one way, which is nice. And again, it is riding on, no, it's not, it's riding on the plastic on the connector. So I'm gonna, fortunately this is just about the right height to get that at 90 degrees. That's pretty cool. But because I can't see it completely, I'm going to do one pin again. Take a look. It's not quite 90 degrees, and again, this, it really doesn't matter at this point, but I just want it to be neat. Now, one thing you got to be a little careful of is now that I've got the panel off and the LEDs sticking up in the air, you got to be careful you don't bang against one of the LEDs and get it misaligned, because when you put the panel back on, it won't fit if you do that, and that would be not a happy time. And that is all the soldering we're going to do on this guy. So put the front panel back on, again being careful with the LEDs, and put the panel nuts on for the last time. Knob on. Now it only goes one way because it's got a flat spot on it. That moves like so. Button push as well. Do one more thing. We'll put the power connector on, and the red stripe goes right there as the circuit board indicates. And it's all together. That's the front, one side, the other side, this side, top, and bottom. Let's put it in the rack and see how it oscillates. Now we're in the rack. Let me turn it on and see if anything catches on fire. Nothing catches on fire. Looks like it's booting up. All the lights are lit. If we look over, let me bring the scope up. I'm surprised all the lights are lit, actually. So the bottom line, let me refigure this. So the bottom line, I'm coming out of out one into my multi, and the multi is going to the scope and then wherever else we want to do it. So let me give you a quick overview. Let me get in front of the camera for a second. Give you a quick overview of what goes on here. This output, the number one output, when we're on the basic, the first set, this is the base frequency. Second output is the base frequency divided by 3. This is divided by 7. This is divided by 11. We can go to set 2, which is divided by 2 for 8. Set 3 is 4, 8, 16. And then we can pick various waveforms. So let me run the frequency knob up. Wow, that's really notchy, isn't it? I'm going to turn the... So you can see there's 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. So the output is being divided by 3 right now. And look at that. I'm a little concerned. That you may notice the triangle wave is a little notchy there. Let me increase the frequency with the frequency knob. Goes real fast, doesn't it? Okay, I'm going to pull that back out. Now, you change the divisions by holding down the button for 3 seconds or more. I think that just changed it. Okay, now it's 1, 2, 1, 2. Now it's 1 for 1, which is not really what I expected. Speeding it up a little bit. Okay, now it's divided by 2. Now it's reading right. That's set 2. Now we'll go to set 3 by holding this down again for a little bit. It's got to rethink itself, and now it's divided by 4. So, oops, dropped my pointy thing, gosh darn it. 1, 2, 3, 1, 2, 3. Oh, we circled back around. Now, one other thing we can do here is by lightly pressing or just quickly pressing the this white button. That changes the waveform. Now you can see it's a ramp. Press it again. Oops, I pressed the input. Press it again, and it's a nice square wave. Press it again, and it kind of does that. Kind of a step kind of thing. That's kind of neat. Now we're back to the first one. Now let's do a little more interesting things with it. Let me take the output from the bass, and I've got my I'm going to put this into volt value, note value. Let's try a different waveform. Try the next waveform. It's just pulses, so it's not doing much, it's going way high. Let's do that step kind of thing. Now we're back to the ramp. Now the next thing we can do with this is I can take another LFO, I've got another LFO in the rack, and put that in sync, and that overrides the frequency button, and now the external LFO is generating the sync frequency. Gosh, that's interesting. It's going very, very... I'm going to back off on the voltage output on that. That's too low. Let me take the voltage output up again. It goes awful fast. So it's reacting to the LFO triggering. Let me put that on an actual sine wave instead. That works a little bit better. I'm going to flick this around. And this, of course, overrides whatever you're doing with this. Now that I've taken it back out, you just move this back and forth, and it goes back into regular stuff. Oh, I'm sorry, I was going into frequency. Frequency modulation. I need to go into sync to do what I was actually talking about before. Now, every time the LFO triggers, it's doing that. So that's kind of interesting, isn't it? So we'll take all that back out and there's the basic operation. I'm going to go to sync this. I'm going to sync it from my sequencer. So that's a lot better than the LFO. Now it's set to the sequencer. I can slow the sequencer down. And you can see what happens. Increase the sequencer speed. Now take sync back out, and it will remember that input until you go back to using the frequency knob. Let me turn that down a little bit. I'm going to take the gate into, this is additive. I had it wrong before, now it's additive. So let me slow the sequencer down. I'm going to go back into gating it. Now I'm going to move down to another of the LFO outputs. You can see that's much longer period on the magenta line. Change wave shapes. So that's what it does. It's pretty interesting. Let me pull this back out and we'll go back to manual frequency mode. So you've got a nice basic LFO that you can set to whatever you want, even though I would have liked a sine wave in here, which we don't have, I don't think. Wave shapes in order are triangle, saw, square, and stepped random. There is no sine, so if you want a good sine wave for, say, frequency modulation on a filter or whatever, you probably want another LFO. This is a supplementary if you just want a sharp pulse. You can synchronize it to any external clock and it'll divide it up the way you want. And it's a good little unit, as you saw, relatively straightforward to put together and works just fine. I think it'll be a nice addition to your rack. And I hope you enjoyed the video.